Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. In this video, we're going to do a question from the November 2019 Grade 12 Physical Sciences Paper 2. This question deals with the titration of a hypothetical strong base called Z-hydroxide with hydrofluoric acid. Questions 5.1 to 5.5 are covered in separate videos, and the answers are not relevant to the ones dealt with here. We are asked to consider the hypothetical strong base given by Z-hydroxide. A solution with a volume of 0.4 decimeters cubed and a concentration of 0.12 moles per dm cubed is prepared. It is then titrated with a solution of hydrofluoric acid. The first question asks us to classify hydrofluoric acid as weak or strong. To answer this question or questions like these, you will usually have to memorize some examples of strong and weak acids. Hydrofluoric acid is classified as a weak acid. While you will have to memorize some of these things, it is also useful to remember that strong acids will ionize almost completely in water, whereas a weak acid will ionize to a lesser extent. The second question asks us to write down the formula of the salt formed in this reaction. We know that in a reaction between an acid and a base, a salt and water are formed. In this case, the salt will be made up of fluorine and our hypothetical element Z. To write the chemical formula of the salt, we also need to know the oxidation numbers of the elements. Fluorine has an oxidation number of 1-, and Z has bonded with two hydroxide ions, which also have an oxidation number of 1-. So from this we can conclude that the oxidation number of Z is 2+, and therefore Z will bond with two fluorine atoms. This makes the chemical formula of the salt ZF2. The third question here asks us to define the term hydrolysis of a salt. Hydrolysis of a salt is the reaction of an ion with water, and in the very next question we're asked to complete the protolytic reaction showing the hydrolysis of the fluorine ion. Fluorine is highly electronegative, so it is very reactive. In this reaction, it will break apart the water molecules into hydrogen ions and hydroxide ions, and then it will bond with the positive hydrogen ions to form hydrogen fluoride or hydrofluoric acid and hydroxide ions. The last question asks us to state the most suitable indicator for this reaction from the indicators listed in the table. Different indicators change color at different pH levels, meaning that the indicator will only work for a neutralization reaction with an endpoint pH within its pH range. As we can see here, the three indicators given change color at low pH, close to neutral pH, and high pH. To determine which one will be best for this reaction, we need to know the pH of the endpoint solution. To do that, you need to recall that the pH of a salt solution depends on the relative strengths of the acid and the base used. Since we have a strong base and a weak acid, the endpoint pH will be higher as the strong base dissociates more than the weak acid, so the concentration of hydroxide ions will be higher than that of hydronium ions. This means we need an indicator that works at higher pH values, and the one given in the table is alizarin yellow. Before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.